So in the previous videos, we were looking at derivations in the format that the textbook uses. And in this video, we'll look at how to set them up in Google Docs and what they look like when you do that. Um, First, we should maybe get a reminder of what these sentences mean. So these here are sets of sentences of SL, right? And this single turnstile means derivability. So this then says that the sentence C is derivable from this set, and this says that this sentence here, M or R, is derivable from this set. So we'll construct derivations to prove this. Okay, so first step, go to Insert, Table. We'll need a 3-column table, and we'll take 5 rows. We need 3 columns because line numbers, sentences of SL, and justifications. So these columns are way wider than we need. So that'll be wide enough for the line numbers. This will be for the sentences of SL. That'll be wide enough to fit in our longest sentence, which is that. And this thing's in the way. That is for the justifications. It just needs to be wide enough to fit in the word assumption. So next step, we will copy the members of the set in as our assumptions. Now, if you notice in the previous videos, the examples there have been using just capital A here instead of writing out assumption, which is the way that the textbook does it. That's a habit that I picked up from writing these things out on blackboards in front of the class. I got tired of writing out the word assumption every time, so started abbreviating it to A. Okay, so for next line, we're going to want to get D from line 2 by conjunction elimination. And then we're going to get A and C from lines, this is going to be 1 and 3 by biconditional elimination. So let's get the biconditional symbol here. I believe it's that one. Yes. There we go, biconditional elimination. And then we will need C, which is what we're trying to get by, this is from line 4 by conjunction elimination again. So now what we have right here, this is fine. This is a well-organized table, right? Everything is actually clear. You don't have a scope line laid out here, but I mean, the assumptions are clearly identified and everything that follows from the assumptions is clearly identified. And so this isn't really, I mean, this is perfectly fine. But I mean, if you want to be more precise with it, then what we'll do is we'll draw in the scope lines. So you would highlight this column, go to this little arrow up here, and then go to this thing here that's got the line on the left. That will highlight this line. Then you go up to here where it has the icon, the lines of varying widths, it says border width, and just make that line thicker. And then we'll do the same thing for the bottom line there. And there, now we've got a scope line the way that the textbook lays it out. Okay, so that is our first derivation. For our second one, we'll start off again with the table. We're also going to need three columns. This one we're going to want to be a little bit longer, say 7. Shrink that down. That one doesn't need to be very wide. Does that? Okay. We will copy the assumptions into the table. Okay. Now, for this one, looking at this, because of the fact that there's this disjunction up here, what I'm going to do to do this derivation is I'm going to use disjunction elimination. That requires subderivations. So to insert a subderivation, what you want to do is right click and go to insert column right. This column here, this is going to be the column for the new subderivation. So the for or elimination, we're going to have two subderivations, one starting with each of the disjuncts. So this one is going to start with M. I'm going to label this as assumption for, get the or symbol here. I believe that's it. Nope. Here we go. Logical or. Assumption for or elimination. And then we're going to go M or R, which we're going to get from line 3 by or introduction. Now we're going to do our second subderivation. And what we want to do here, because having two consecutive subderivations at the same level in a row, when they're not nested the way that these are, right? Where this one, I mean, they're nested in the sense that this one is further over than this one is. These ones are going to be right in a row. That gets confusing. So we're going to put a blank line in between them to make it clear that these are separate. Because you can see, right, that these, when you put in the scope lines, they're going to go all the way to the edges. They don't have the little gaps in them the way that the ones in the textbook do. And so these are going to end up looking like, like they're the same subderivation. So just put a blank line in. So this one here is another assumption for elimination. And then we are going to get R by, this is going to come from lines 2 and 5 by conditional elimination. Now we need a new, we're out of rows, so we'll go right click and go to insert row below to get another one. And then we're going to get M or R by or introduction. I'm actually just going to copy these two cells here and then just change the line number on that. Remember that or introduction works on both sides, so we can just insert an M to the left of this R using the same rule. Okay, now we have the same sentence in both of our subderivations. So we add a new row, line 8. At this point, we're out of these subderivations, so we're back over into this column here. We're just going to copy this here, and then we put in our justification. The justification for or elimination is you cite the line that the disjunction's on, then both subderivations, and then or elimination. So we will go 1, 3 to 4, 5 to 7, and then I'll just call it or elimination. And again, this is a well set up derivation, right? It works out perfectly fine. We can still draw in the scope lines though, using the same procedure as we did last time to make it look a little bit nicer. So we'll put these in like this. Here, and then remember that they go under the assumptions. So it's going to go here. Remember not to put it under the entire subderivation, right? It just goes under that first line, which is the assumption. And then here. And then if you really want to get fancy with it, what you can do is, I think you have to do one at a time. Go to this and go merge cells. You can take out that middle line there. In these, and then you can actually go and move this whole column over because it doesn't need to be all the way over. If you look at the way that they are in the textbook, right, they're not indented that far over. They're just indented enough that you can see that they're separate. So we could actually move that over like that, redo this line down here. So this thing extends all the way over. And there, that looks quite nice. You can also actually go through if you want, you can go and you can clear these outer lines and things like that so that you would only have the scope lines left. But that's a ton of trouble, and I'm not going to do that here. Um, any of the ways of formatting these things are good. The really important thing is just that the most important thing really is having all of the subderivations separated off and in separate columns so that each one is clearly separated off and it's clear in each case which one is a subderivation and which one is, so that it's clear then which lines are being derived from additional assumptions beyond the primary assumptions that you started with.